Today we will be discussing Newton's third law. So the definition of Newton's third law is for every action there is an equal and opposite reaction. So what does that mean? This means is always how many forces in a system? Two forces in a system, at least two forces. So how can we derive or figure out Newton's third law formula? Well, simply put, it is the force of 1 to 2, 1 to 2 being our two forces in the system, is equal to the opposite of such from 2 to 1. See how both of our applications of the definition are applied? We have our equal here, and then we have our opposite. So if you can imagine, there's a little addition plus sign here. So we have our positive and we have our negative value. So let's provide an example of this. Let's say you are jumping off the ground. So we'll just draw some ground here. So if you're just standing casually on the ground, like so, you have the force of gravity pulling down on you, labeled mg, and you have that normal force pushing back on top of you to keep you in static equilibrium. Now, when we jump, we'll draw a little guy jumping here. Don't know how well my drawing is going to be with that. But when we draw him jumping, those forces are still applied as equal and opposites. You still have the force of gravity pushing down and that normal force pushing up. But that normal force is now being applied because you jumped off the ground. That force is being applied as you go up. So how does this connect back to Newton's first law with a box on the table? So let's draw a box on the table. And of course, this box is in static equilibrium. Well, in Newton's first law, it said an object at rest will stay at rest. And we knew why, because there was no net change in the force. So let's draw our forces here. We have our normal force and our gravitational force. And if we apply the formula that we talked about earlier, if these are equal, then we can say if our normal force is positive, then our force of gravity is going to be equal to the opposite but equal value of such. So that's just going back and saying with our formula for Newton's third law that this is true. So we can see how the laws connect and how the first law can be explained with the third law and how they're interconnected with that. So with that, we're going to take some application and we're going to answer some questions. Our first question here says, two masses, m greater than m, capital M greater than lowercase m, are connected by a light string hanging over a pulley of a negligible mass. When the masses are released from rest, the magnitude of the acceleration of the masses is. So we're trying to look for a formula that derives a certain answer for acceleration. So what we're really looking for here is acceleration. What will be the acceleration of that system? Well, let's break our two masses apart. We'll have big M here and little m here. So for big M, we know our Newton law formula, force is equal to mass times acceleration. We know we could say that if it's on a pulley system, that it's going to be the mass of big M times gravity minus that tension that's provided. We'll abbreviate the force of tension with F of t. And that's going to be equal to, in this case, our big M times acceleration. So we figured out that. Now the smaller m, is that going to be the one that's going to move compared to the bigger m? Well, yeah. So we'll say that our small m is going to be considered our negative. So we'll still write our formula like this. And then we'll say that the force of tension is positive and that the mg is negative. So this is going to be where up is positive and this is where down is positive. And that's going to be equal to ma. And what can we do? We can combine and solve these. So if we combine and solve, we find that mg minus ma plus mg. See how we're substituting for the force of tension here from up here? So if we just go up here, I'll show that math here. mg plus ma. See how we're getting that? We're just substituting our force of tension for this is equal to our mass times acceleration of the big M. And if we solve for our variables and everything of the such, we're going to end up with something that looks along the lines of this. We're solving for our acceleration things and gravities because we're trying to solve for A, right? So what do I do here? I'm going to divide, and I get big M minus little m over big M plus little m multiplied by g is equal to our acceleration. And is that one of our answers? Of course it is, because we solved properly and we determined the definition of our system and where that movement would be. So on the AP exam, if you're striving for 5, you're going to use the tools that you found in many different multiple choice questions to lead yourself to the path of righteousness and apply it to different problems. So let's read this one. 2 masses are hung and are connected by a light cord and hung from a frictionless pulley of negligible mass as shown. Same language as the other question. Mass M1, 3.0 kilograms, and mass 2, 2 kilograms. When the 2 masses are released from rest, the resulting acceleration of the 2 masses are approximately, well, what did we just figure out in our last question? Well, we figured out the acceleration is just going to be gravity multiplied by big M minus little m all over big M plus little m. So we don't even have to try to derive or figure out what's going on here. We know the formula. So all we have to do is essentially plug and chug. So we can say A is equal to 9.8 multiplied by 3, because we're going to use our bigger mass here, minus 2 all over 3 plus 2. And if we use our handy dandy calculator, we'll see that A comes out to 1.96, which in this case is going to be rounded to 2 meters per second squared, because we always want to include units. So what does that mean? Well, that means our answer for this question is B. And I hope that was a good reflection of Newton's third law.